Hi guys, welcome to my channel. Fanny here. I'm a med student here, and if you haven't already subscribed to my channel, please don't forget to subscribe and hit that notification bell button so that you receive notifications whenever I post new videos. I'll be posting new videos every week. I'm kind of new to doing this, but I'm excited to be doing this, and I'm going to be taking you through embryology and a whole lot of different medical topics and courses, and I hope to be able to help one of you guys out of the stress of med school. So today I'm going to start a series of embryology, and we'll be moving from head to toe. So we will start with the nervous system, and we know that the nervous system consists of the brain and the spinal cord. So we're going to be looking into how those structures form, because it is also essential in helping us to understand further concepts and topics in physiology, in neuroscience, in anatomy, and all that type of stuff. Alright, so let us get right into it. So we shall begin with the central nervous system. Okay, alright, so first thing we need to know is, when does this occur? When does it appear? When do we begin to see the central nervous system appearing? So it appears or begins to form within the 3rd week of gestation, alright? Yeah. And when it begins to form, it will begin to appear like a slipper shaped, more like this. Pardon me, I'm not very good at drawings. My art is quite rather, but it will appear slipper shaped, right? It will appear slipper shaped. It will appear like a slipper shaped plate here. A slipper shaped plate of thickened ectoderm. Okay, so now that thickened ectoderm is what we are going to refer to now as the neural plate. So guys, this is very important for us to know in this, because it's going to help us understand the basis of a lot of things. So now going back to this drawing, this very nice drawing of mine. So we said this is a slipper-shaped plate that has thickened ectoderm that we know as the neural plate. So now you see this has edges on both sides. So these lateral edges are what we're going to refer to as neural folds. But now, in my med school, I found that when I was doing embryology, I found that it is much, much easier to understand it when you can picture a schematic, picture what is going on. So we're going to do just that and see how we work out from there. So we have this neural plate that forms, that is thickened ectoderm, and that thickened ectoderm is going to give rise to those lateral edges that we will know and refer to as neural folds. So there's a lot of folding that takes place as the human being is developing. So now as these folding occurs, as these neural folds appear, they will begin to fold. These two edges will begin to fold together. And when they fold, they will form a narrow tube that is known as a neural tube. And that neural tube is very important because it's going to give us two things. The first one is a cranial end, or a cranial neural pore, and the second one is a caudal neural pore. So just so you understand, cranial always means head, or towards the head, and something else you can use to refer to is cephalic. Then caudal is tail, so towards the bottom. So cranial is towards the top, towards the head, and cranial is towards the limbs or towards the legs. Okay, so now before we even move on to see what these are going to give us, you need to know that the cranial, that folding, fusion here of these neurofolds is going to begin from the neck area, and from the neck area that is known as cervical. So it will be from cervical to cephalic or cranial, and also from cervical to caudal. So it will be more like these things are happening in a synchronized manner. They'll be happening at the same time, cervical to cephalic and cervical to caudal, or neck to head and neck to legs. Okay, let's get right into it. So we said our cranial pole, we can also refer it to the cephalic end. So now this cranial pole is going to do some very important things for us. So first, it is going to differentiate into some 3 primary brain vesicles. Alright? And don't worry about the caudal end, we shall get to the caudal end soon. But it will differentiate into 3 primary brain vesicles. And what are those primary brain vesicles? Okay, so the first one is the prosencephalon. And as you can see, cepha is coming from cephalic, so the head, prosencephalon. So this becomes our future forebrain. What is the second brain vesicle? So the second one is going to be our mesencephalon. So this one will now become our midbrain, our future midbrain. Mesencephalon, midbrain. Then the last one is going to be the rhombencephalon. Rhombencephalon. So this is going to be hindbrain. Okay? Alright. So this is some good stuff right here. Okay, so before we even get into what each of these 3 different brain vesicles differentiate into, we need to know and remember that at this cranial pole, apart from it differentiating into these 3 primary brain vesicles, it's going to form flexures also. Sorry. Pardon that. So it's going to form flexures. And some of you guys might be wondering, what are flexures? So flexures are like bends or turns. So it's going to form a flexure around the cranial end, and it's going to form those flexures at 2 points. So the first one will be at the rhombencephalon, or at the hindbrain. So it's going to form a flexure between, so this will be at the junction between the hindbrain and the spinal cord. So this is the first flexure that is formed, right? And then the next one, it will go and proceed and form a flexure or a bend at the midbrain or the mesencephalon. So that one will be known as the cephalic flexure. Alright, that's some good stuff here. So now we're going to look at what these three brain vesicles differentiate into. So we have the prosencephalon, the mesencephalon, and the rhombencephalon. So now with the prosencephalon, which we will start with, the prosencephalon is going to, alright, maybe even before I get to here, you need to know, let me extend this arrow. Okay, so before we even get here, you need to know that the cranial pole, after differentiating into these three primary brain vesicles, will now go on to differentiate into furthermore 5 primary brain vesicles. So the first one will be the prosencephalon, which will differentiate into two things. So it's going to differentiate into the telencephalon. The telencephalon. Okay? And then it will also differentiate into the diencephalon. So now what's going to be our telencephalon? Our telencephalon is going to be our future cerebral hemispheres. So this is where we have the left hemisphere, the right hemisphere of the brain, and then the diencephalon is going to give us the eye, things related to the eyes. So we're going to have the optic vesicles. We're going to have the optic vesicles. We're going to have the thalamus. We're going to have the hypothalamus, and we're going to have the pituitary. Okay. All right. So prosencephalon will give us 2 more brain vesicles. That's going to be telencephalon and diencephalon. So now our mesencephalon is going to remain the same, but this one is going to give us, I'm running short on space, guys. Okay, so the mesencephalon is going to give us our anterior visual fields. It's going to give us our anterior visual fields. Okay, and then it's also going to give us anteriorly is going to give us the visual fields, and then posteriorly is going to give us the auditory areas and auditory colliculi. Yep. Okay. Then we now go to rhombencephalon. Oh my gosh. Okay, rhombencephalon is going to give us 2 further brain vesicles as well. That is going to be metencephalon and myelencephalon. Okay, so this one will give us that. Metencephalon and myelencephalon. Okay, so now the metencephalon. What is the metencephalon going to be? So the metencephalon is going to give us our cerebellum and the pons. And then our myelencephalon is going to give us our medulla oblongata. Okay, perfect. So now we have we have these things right here. So just something to know before we even move. So you see, we have the midbrain and the hindbrain. So between the mesencephalon and the rhobencephalon, we are going to have what is known as a rhombencephalon isthmus. So this rhombencephalon isthmus is going to separate the metencephalon. It's going to separate the metencephalon from the mesencephalon. Okay, so the isthmus is there to separate metencephalon from mesencephalon. Okay, all right, that's good. So now further we see that we're going to see something else happen here. So this is still our rhombencephalon, metencephalon, myelencephalon. So now within this area, we're going to have cavities that are going to form. So the cavity that will form here is the fourth ventricle. And then when we come to the prosencephalon, we're going to see another cavity that will be formed on the telencephalon, that is the lateral ventricle, and the diencephalon is going to give us the third ventricle. Now, I'm sure you might be wondering, what about mesencephalon? Does it form anything? So mesencephalon is going to have like a very important lumen. It's going to be a very important lumen that is known as the aqueduct of Sylvius. So this aqueduct of Sylvius connects the third and fourth ventricles. Okay, so I think today this is where we will end. So I'm just going to give a quick summary of all that we have done today. Okay, so this is embryology of the nervous system, looking at the CNS. You need to remember that the central nervous system begins to appear or form within the third week of gestation, and it appears like a slipper. So it's like a slipper-shaped plate, and this slipper-shaped plate has thickened ectoderm. And on the lateral edges, we have neural folds that are going to form. So here, looking at it here, folding begins from the neck area, the cervical to cephalic, and from cervical to caudal. So first we have the neural plate, which is the thickened slipper-shaped ectoderm. It forms neural folds, and these neural folds, they fuse. A better word is fuse. So these lateral edges are going to fuse and form a narrow tube, which is known as the neurotube. And this neurotube divides into two parts, the cranial end and the caudal end, or neural pole. Cranial, also known as cephalic, and caudal, tail, or towards the legs. Then, first, we only looked at the cranial neural pole. So, first thing it differentiates into is the three primary brain vesicles, and we see that these are the prosencephalon, which is the future forebrain, mesencephalon, which is the future midbrain, rhombencephalon, future hindbrain. So between then And the cranial neuropore also forms a flexure, which two flexures at the rhombencephalon end, which is a junction between the hindbrain and spinal cord, and the cephalic flexure at the midbrain. Okay, so now prosencephalon differentiates into two brain vesicles, telencephalon and diencephalon. And telencephalon is the future cerebral hemispheres, left and right. Diencephalon is the future optic vesicles, thalamus, hypothalamus, and pituitary. Then mesencephalon remains as it is in the midbrain. And then rhombencephalon or hindbrain differentiates into metencephalon and myelencephalon. So metencephalon would be the cerebellum and pons, myelencephalon would be medulla oblongata. Then, yes, so, so further, we have the rhombencephalic isthmus, which will separate the mesencephalon from the metencephalon, and the cerebral hemispheres will further form the lateral ventricle, diencephalon. These products will form third ventricle somewhere, and the mesencephalon midbrain will have a lumen, which is known as aqueduct of Sylvius, connecting third and fourth ventricle. Fourth ventricle is a cavity formed at the rhombencephalon. So I hope you guys liked this video. So please don't forget to like and subscribe. I'll be back with you with the next video on the spinal cord.